The broadcast is now starting. All attendees are in listen-only mode.
All right, would like to welcome everyone back to another KevCAM Night class tonight. Tonight, have Brendan McKenna helping out with any questions or concerns for everyone. Brendan, are you with us?
I sure am. How you doing, man?
Doing good, doing good. Still
Excellent.
recovering from turkey belly, but we'll live.
Yeah, no kidding. It was kind of funny. You know, my daughters were here, so I did two different styles of turkey that they requested, and neither one of them enjoyed the opposite ones that they requested. So, yeah, it was good times. Yeah,
Good deal.
fantastic.
And then also have Greg Payton here to help out all the way from where are you at this week, Greg? Arizona?
This week in Arizona. Yes. Good evening, everybody.
So tonight I do see all the regular names in here, no new names, so we won't cover any of the housekeeping stuff. But my main focus for today is 3D iMachining, and what I wanted to do is focus on all the capabilities of 3D iMachining. But first, what I would like to show you guys is how you can use 3D iMachining in a 2D environment. So with that being said, we can get the ball rolling here. And what I want to do, you'll see this part is 99% of it is all prismatic part. And what I mean by prismatic is flat floors, vertical walls. We do have some taper over here, but it will pick that up for us. But like I said, we've been, over the last couple of weeks, we've been kind of showing you guys, thinking outside the box a little bit, using operations where you wouldn't think to use them. And this is definitely one of them for you guys. So for those of you guys that just have 2D iMachining, definitely pay close attention on how well 3D iMachining can affect your 2D parts. So, all right, so running this on a Haas SS, and we'll just hop right into, well, let's back up one step here. Inner part setup, for those of you guys that haven't seen the 2D iMachining video, we're telling it what machine that we would like to run it on, what material that we're cutting, as well as a default machining level. And we'll cover this when I get the operation open, but in here is, like I said, what machine are we running? Now, for those of you guys that haven't utilized this, to add a new machine in here, we can just click on Edit iMachining Database. And once it pops up here, we can come in here and add a new machine. And there are just 3 parameters that we like to get from you, or we need from you, to utilize the iMachining algorithm. Now, this is going to be the same for 2D iMachining or 3D iMachining. This is something that you do not need to create every time. Once you've created it, it's put it into your iDatabase forever, and you won't have to worry about it. But for those of you guys that are new with the iMachining, come in here, give it a machine name, max RPM, max feed rate, as well as horsepower. So those are the 3 key variables that we're looking for, as well as the material. So if we are looking to add a new material in here, the default materials in here are, very conservative, we'll say that. Or not very conservative, just conservative. Plus, they are all metal. So we have aluminum, stainless steel, tool steel, regular steel in there, titanium, stuff like that. But maybe you guys would like to cut PVC or REM board or anything like that. And for that particular material, you guys can actually go open up your internet, and we use the website. It's called matweb.com. And right here, this site will give you all the material dynamics that we're looking for iMachining. So just for example, I'll just do a 6061 here. And then we'll want to find the one that best fits it. So we'll do our aluminum T6 right here. So we got aluminum 6061 T6. Now the variable that we're looking for in here is the ultimate tensile PSI, which is right there. Now you can see we have at multiple different temperatures right here, but the top one is our ultimate tensile PSI that we're looking for. So what we can do is create a material off of that. Now, this does not have to be metal at all. If you guys, if I come back here, and we have a couple of our customers doing wood. So we can just type in maybe red oak. And Brendan likes to go with the European style, so we'll go with the European red oak.
Well, you know, I mean, it always is. It's, you know, it's kind of one of my favorites, you know. So.
And you can see right here, we have an ultimate tensile PSI of 479. So what I guess what my main thing I'm getting at here with you guys is the sky's the limit on the material that you guys would like to cut, all the way from foam, like I said, cardboard, rem board, all that stuff is in there, and you guys can definitely add those in there as well. So
Hey,
yep.
Kevin, just a quick question. Matt Webb, does that require like a subscription or anything
Nope.
like that? Or
Nope. This is 100% free, and it is a supported by SolidWorks. I think I've seen it on, yeah, so we got SolidWorks right here, Autodesk, Space Claim, a couple other ones here, but it is 100% free, no login or anything like that. Now, if you can't find your material in here, or let's say for whatever reason you can't find the ultimate tensile PSI, you can always get that from your material vendor as well. So we'll have all the specs on that also. So just eliminate one extra phone call to the vendor. And then you guys can add that material in here with the ultimate tensile PSI. So like I said, the ones that are in there are conservative. And if you guys really want to maximize your efficiency, definitely come in here and create that material. All right, so we have our machine, and we also have our material that we're cutting. So now we can get into the iMachining side of things. So we'll do a 3D iMachining here. Now, in here, if you guys look at the top left, we have a drop down. So we have 3D General, which is going to be geared towards our 3D surfacing parts. And, you know, even on a part like this, we do have a 3D, so it would take an X, Y, and Z movement simultaneously. Or we also have Prismatic, which we talked about, which is the flat floors, 90-degree walls. So you can use 3D General on a Prismatic part as well, but the option is there for you guys. And I'll show you the difference between 3D General versus 3D Prismatic. So starting at the top, what do we want to cut? So we are looking at cutting the target. If you guys have multiple targets and you just want to focus on one area, you can do the new option right here. And we can select right on our model. So you guys can contain it, as well as a working area. So maybe we just want to focus on a specific area. We can tell it we just want to work contained into this area with doing a internal, external, tangent, and center right there for you. So you guys can create your own bounding box. So with that being turned off, what's going to happen is 3D iMachining is going to look at the stock versus our SolidWorks model or a target and machine everything off in between. Now, the cool thing that they have built into this is full fixture detection. So we can tell it to stay away from a fixture by a specific value. We have full tool holder collision as well. So there's, as well as it's not going to shank out or run out of flute for you guys. So it is definitely the easy button as for machining. So right here, we can go to our tool. And we can grab our tool in here. So we're using a 1/2-inch 2 flute here. Levels, something I don't even need to worry about, but if you guys want the control of keep it contained above a certain level, or based off of levels, if you just want to go down to a certain height with one end mill and then come back with that additional, I'm sorry, I said height, depth, and then go a little bit deeper with a different tool, that's where we can come in here and change that. But for right now, what it's doing is it's looking at my stock. So the top of my coordinate system down to the bottom of my stock right here.
Hey, Kevin.
Yep.
Quick question. I get this all the time, and maybe you can just go into it just super briefly. But you were talking about tooling, not to go backwards here, but if I had a specific tool, like let's say I had a tool library that was imported from, say, Kennametal or you know, whoever else, ISCAR or whatever else is out there, can I import that into SolidCAM?
Absolutely, yeah. Any of those tools that are coming in, you guys can definitely import those into there. Along with, you know, they'll have their recommended feeds and speeds that are in there. But one thing I did completely glaze over is with the tool data in here, there's no need to have to figure out what feed rate, what spindle RPM, how much to take per pass. It's all done with the algorithm based off of what machine, like we talked about with the feed horsepower and spindle RPM, as well as the material that we're cutting. It is going to figure out all those feed rates for us. So
that's awesome.
The nice thing in here is, so we are using a 1/2-inch 2-flute end mill. I'll bring it back up in here. Oh, I'm sorry, 5-flute end mill. This is going to tell us, I mean, this flute number is very important to know because it's all, that's kind of how we're calculating our feeds and speeds. So with that 5 flutes in here, we can actually come in here and do almost like a sanity check to see if that tool is ideal for the cut. And by doing that, we can go right to our technology wizard right here, and we can see that this area is in yellow right now. Now that's telling us that that tool will cut it without any issues, but it is not the ideal tool in there. So the ideal tool, this will be green, but you guys will see 3 different colors in here: red, yellow, and green. And if you guys do get red, that's nothing saying that, oh, no, can't use that tool at all. It's just not the, you won't get the optimal performance using that tool or the longevity using that tool. So what we can do a little testing.
Well, you know, the thing about that, Kevin, too, is like, it's amazing to me that, I mean, this is going to tell me what tool is really the appropriate tool. I mean,
absolutely.
How much easier could that possibly be?
Back to hitting that easy button.
You know, it's amazing.
So what we can do in here is we also have the iData tab right here. So right now we're using a 5-flute with a 45-degree helix. But let's just kind of take a look here and let's switch it over to a high helix. Now, even though that I'm using this drop down here for the helix angle, you guys can type the number in there. So let's say we're using a 50-degree. It's going to automatically grab that 50-degree for us, even though that it's not a drop down pick. You can type the number in there. So let's just try our 50-degree end mill here, or 50-degree helix. And now we're green. So a lot of these variables come into factor, determining how good that cut is going to be right here. And you know, how many flutes, the diameter is all, it's all based off of the ACP, which is the actual contact point of the material. And if we nerd out a little bit here, let me get to my, there it is.
Yeah.
So when we're talking,
we know you like to nerd out a lot.
Oh, absolutely.
Okay. Just take that ball and run with it, man. Just go.
So right here is our flute angle of engagement. So basically the ACP is the actual contact point of that flute engaging into the material. So that ACP value will change based off of the number of flutes that you have versus the diameter, helix angle, and all that. So sometimes you will have green in here with the ACP of maybe 1.0. where when we were yellow here, we were at an ACP of 2 point, I think it was 2.4, something like that, but it was still coming in yellow. So it's
Yeah,
really,
that's going to be a vertical representation of the tool, right? How many points of the flute are in contact with the material?
Yep. Sorry. So if we go,
yeah, we need like a side-on view instead of a top-down.
well, I can't get the flutes to show up, so.
Yeah, I'll see if I can get you an image of it, and we can circle back on it.
Perfect. So now, all right, so we have our geometry, which we didn't have to pick. We're grabbing all the geometry. We have the tool, and basically that's it. And we can come in here and decide how aggressive do we want to be. And for those of you guys that are running 2D iMachining already, or 3D iMachining, this is going to be a little bit of a repeat, but basically the iMachining level here is how aggressive do you want to be into the cut. So if we are running level 8 here, we're going to want a good tool holder, good clamping power on the part, because we're not going to want to run this part on a vacuum fixture running level 8. We're going to get too much pressure from that tool. So good vise, good tool holder, good tooling and stuff like that. Now, if you are running more on that vacuum table side of things, then dial it back down to that 2 or 3 mark. So, and you know, once you guys run one part in here, you'll know what the sweet spot is. And then one thing to remember is once you have that dialed in for maybe even that material and that end mill, create a template out of it, because there's no reason to come in here. We're always using this 1/2 inch 5 flute end mill to hog out our material. There's no reason to come back through here and reapply everything that we've already done before. So, all right. So we'll crank this baby up to level 8, and let's just go ahead and save and calculate here. And basically what's happening is it's looking at the SolidWorks model, our target, versus what we have for stock there, and is going to machine everything off in between. Now this path will change once I show you guys into the technology page here. Okay, so now we're coming in here, machining out all these different cavities in here, as well as doing our 3D functionality right here, tapering up this wall. And this is where our scallop comes into factor. So in the technology, we can tell it, do we want a scallop or a constant? And the difference is if we're doing a scallop, that scallop from peak to valley is always going to be this number right here, our 82 thou. Okay. Now, if we switch it over to a constant, it is constantly going to be stepping over that specific amount. With that being said, though, what you'll have is a higher scallop in certain areas and a smaller scallop on more of a flat area, or I'm sorry, more of a vertical area. You'll have less of a scallop there, which is going to, lead to uneven load and load on a finishing end mill when it's coming in there and going back and forth for you guys. Now, you guys can change the scallop in here. And if we're looking for something really small, so we can come in here and do, 25 thou scallop. Now take a peek. Let me get a side view here. Now, when we go to save and calculate this, it's going to add quite a bit more tool path just on this 3D pass right here, because we're basing it off of the scallop height versus, I think it was 82 thou versus 20 thou. So we should see a lot more passes going on right here.
Hey, Kevin, just, while this is calculating, could I ask just one more question? Because I get this all the time. Yeah, so a lot of people are asking, so when in the previous view, like that isometric view, you could see the tool spiraling down, and then from the middle of all those pockets, can you, like for whatever reason, if you wanted to enter those pockets at maybe say, like the tangent of an arc, or, somewhere along, like at a midpoint of, of a pocket. Is that possible to control?
It is, it is to a certain extent. So if we're wanting to start in a specific area, what we'd want to do is almost drill out that area or create a little pocket, like a starting platform. Because what it's going to do is it's going to, based off of the algorithm, it's going to try to start from the center and work its way out always. Now, if we start far on the right side and work our way across, we're not getting the most efficient cut that way. And that's why we don't start from the corner. We always want to start from the center.
Absolutely. And I hope you understood the reason why I asked that question.
Yep.
Because because it's amazing every single time I look at these toolpaths, and I'm like, they're so efficient, and they a lot, again, I mean, it's just like you talked about in the first episode of this series, or this video.
Yep.
It's like, okay, wow, they're, you always have complete control over that chip thickness, and it's amazing to me. I love it's great.
See, you can nerd out too, Brendan.
I'm totally nerding out. I mean, it's funny because, like, every time we always watch these videos and everything, I'm like, yep, make it go faster.
Yep. So now you guys can see right here is our scallop. So you can see our scallop is much closer together in there versus having it more spread apart. Now, with that being said, what we can do with this, and it's not recommended at all, but if you guys do have a part that does have quite a bit of tolerance or leeway on your dimensions, and we actually did this at Toyota, is they were coming in there and doing 3D iMachining for everything, and they wouldn't have to do a finish path. Where one thing to remember is when you're using 3D iMachining, this is a roughing strategy. So with that roughing strategy, there is we're always leaving material on the wall. Now, like I said, if you guys have a pretty wide open tolerance in there, we can put these at 0 for a wall offset and a floor offset, and we can get up to size. But like I said, it's dependent all on your tolerances there and your machine rigidity there. So like I said, you can do a rough and I'm not going to even call it a finish, but you can rough it down to size. In some areas, like when we're arcing off and arcing on, we may have just tiny little witnesses marks there, right? Because when we come back, usually with a 2D iMachining finishing pass, we get that one nice, smooth, constant all the way around our geometry. Where here, you can kind of see we're still arcing on, arcing off, getting that material removed out of there as fast as we can. So the option is there for you guys to utilize that. It's not, like I said, it's not recommended, but if you have the parts with the open tolerance, or, you don't have to worry about holding, really tight tolerance areas, this is an option for you guys. And as you can see, we whipped through that pretty quick. So all we had to do is grab a tool and basically how aggressive do we want to be in that cut, and we can hit save and calculate and go. So, and I think Greg sent us a photo here. I can get this moved over to this side here.
Yeah, this would be a graphical representation of what those axial contact points are referring to.
Yep. So basically, as this flute is coming in contact, so we have a flute right here, we have a flute right here, and a partial, or we can say somewhat of a partial down here. And this is a section view of what's going on here. So, on something like this, we could say it's a 2.125. I mean, I'm not saying exact numbers here, but I mean, we can kind of see we got 2 full flutes right there and a semi of a little piece down here. And that's kind of how the ACP is calculated. So does that, hopefully that, if it doesn't make sense, write it in the chat or the questions for us. All right.
So what you're looking for is an ACP that is closest to a whole integer. So the closer you are to a whole number, the less vibration, less chatter you're going to get out of that cut. So like what you were showing, Kevin, where you switch it up to a higher helix.
Yep.
That just gave it a better chance of being in contact to that integer. Other things that we can do is we can change the step down to be closer to that integer value. And depending on the type of machine you have as well, you can set the ACP values in that initial machine definition. So if you have a highly rigid machine and setup, you can definitely increase those numbers and stay within that green factor. Or if you have something that's going to be less rigid, you can decrease that. That way, that color gradient is going to be representative of the machine that you're working on.
Yep. And to kind of show you where that is for everyone. So if we go to Edit iMachining Database, so right here you can see the ACP tolerance. So by default, it's gonna, I think it's set up to 20%. Yep. Some are like the Sharpen is set to 15, depending on the machine. Now a Haas, I would assume that's going to be, yeah. So we got 50%, and this is on the Haas tool room mill. So definitely depends on the rigidity of your machine there. So great point, Greg. Okay, so getting back in here now, we can see if we, like I said, not recommended at all for those tight tolerances, but if we wanted to, we can take a 3D iMachining toolpath and turn it into a one-step finishing path right here. So we're going to be roughing out this entire part here with being able to get pretty good results. I should have saved and calculated before. And
you know what?
This is calculating. Oh, go ahead.
Oh yeah, no, Kevin, I was just going to say, as it's calculating. I mean, that's a pretty amazing thing to do, to take a toolpath that is looking at at it three-dimensionally, and then automatically can just sort of recalculate itself to become even more efficient. Yeah, that doesn't happen.
Yep. And we set this up with a scallop of 20 thou. So we're going to still see some steps going in here. But like I said, if there's something that you're not looking for a real high tolerance, and, at least from what at my old job, it's a lot of times we just got to hurry up and get the part out the door scenario, or to do a repair on a different machine, whip it out and get it done as fast as possible. But you can see, right here, we do have a little bit of a line right there. And what you guys see in your Solid Verify is definitely going to pertain to what you guys are seeing out on the shop floor there. So like I said, this is only in a case where you do have a wide open tolerance area. So, okay, so that is 2D. Oh, I was going to show you the difference between 3D General and 3D Prismatic. So the only difference between these two is one is going to have this section right here. So we can tell it how much of a scallop we would like to have on there. So if I switch over to Prismatic, you'll see that area has been cut out for you guys. So there's your difference, is just based off of scallop. So it will still recognize that this is a 3D feature, and it will still cut that 3D feature. So let's just save and calculate here. Need to get that elevator music going.
Yeah, I was going to say, do you have one of those like like 3D6 or something? The old 3D6 from 1984. Is that what you're running here, Kevin?
Brendan, that was when I was born.
Wow. Okay. I appreciate that. No, that's good to know. Love it too, man.
Brendan's not feeling very good right now.
No, it's okay. It's okay.
All right.
Actually, that being said, while this is calculating, I think it's probably a good time to talk about, what are the requirements, system requirements. And so for those of you who are running SolidWorks, SolidCAM and SolidWorks basically require the same thing. So we can actually post that in the chat as well. Is that accurate?
Yeah, absolutely. And if you guys do run across a scenario where you're looking for recommended computers, you want to send it over to your IT department, I can, as soon as I can find it, recommended computers. So here's a good starting point. I would stay away from the basic, but definitely go with the mid-range or higher. And I'll put this into the chat for everyone to see. But if you guys are looking for a computer, oops, chat. This is a great place to start for you guys. So, as well, I mean, we always talk about tech support, and if you guys are at that point, definitely give us a call. Myself and all the other tech guys, we know computers inside and out. What computers are going to perform better for different scenarios. If you guys are running parts like this on a day-to-day basis, there's no point in having that powerhouse computer where you're going to pay a lot extra versus if you guys are doing really large 3D cavity molds is where the higher performance computer is going to come into factor for you guys. So, okay. Any questions on this 2D part here before we hop over to 3D?
Kevin, I've got the chat area open, and I don't see any questions so far.
Okay. Greg, did I anything else I should show on the 2D before we hop over to the 3D?
I think it looks pretty good right now. One thing of note from earlier on, you were talking about selecting a model individually if you had multiple models. Just wanted to reiterate that if you're going to do that, you want to make sure that you have a working area or select all the models that are encompassed by that stock.
Yeah.
Because if you only have one 3D model selected, it will cut all the stock up to that model.
Great point.
So just be aware of that when you're selecting different models.
And so what Greg is saying is, let's say we had 4 of these parts on the line right here. Even though that we only have selected the one model, iMachining is going to see those other ones as stock because they are listed as your stock in there. So what you get, what Greg's getting at here is, let's say, like I said, I don't have it on the screen right now, but if you guys had 4 of these parts, come in here, do your working area, and then just chain it up like anything else that you guys have done before. And now we have a working area where the toolpath is going to stay contained to that working area as well. Now, if we need to go a little bit further outside, you guys can offset out the toolpath right here. So maybe maybe our stock is varying a little bit on this part. Definitely set your external to a little bit larger, and then it will expand past as well.
Yeah, the instances are going to be very rare where you want to do 3D iMachining on any specific part if you have material removal for a lot of parts. But just keep it in the back of your mind whenever you're deviating from the target model selection.
Absolutely. Okay, so right here we have 3D part. This is part that we actually use for our HSM, and everyone, well, actually that last part, for those of you guys that would like to play with that part, it is part of your install parts. That is the 2D iMachining part that I just showed. And now this part is the HSM one. And you can see I've suppressed all the HSM operations for this one. Starting at the top, they were doing a HSR, 2 different HSR operations right here, but we had to tell it what areas to keep it contained to. We had to tell it what feed rates, different areas, what the scallop or the step down was going to be for those specific areas, where now, this is my favorite part. Open up our 3D iMachining here. Thought I clicked it.
I'm not sure if you heard that that beep, Kevin. That was my Amazon confirmation of your Christmas gift coming your way. So just want to let you know.
I'm scared.
You should be, man. You should be.
Did I say I was born in '84? No.
No, not at all.
Okay, so we got our target, and like I said, it will find the target automatically for you if you do, like we were just talking about. You guys do have the option to do a show, and it will highlight the target for you. But so we don't have to really worry about a working area here. But now what I'm going to do is come in here, and I'm going to grab that same tool that we started off with right here. But we're able to keep it, we can do multiple tools all within one operation now. So this one, they were doing a roughing strategy with a 16 millimeter, and then jumping down to a tool number 2, which is sorry, every time we go live, my computer slows down.
No, I was going to say, I'm not sure what it was. There was a little bit of a glitch there.
Yeah. Okay, so now we're going to the 8 millimeter. So we're starting off with a 16 mil, hopping down to 8 mil, and then if you guys wanted, you can keep jumping down in tools and sizes. So what it's going to do is we're going to rough out as much material as we can with that larger end mill. Whatever is remaining left over that 16 millimeter couldn't get into, it's going to come and do the 8 millimeter in there. So you can keep it contained all to one operation now, do multiple tools, however you want, and you can keep just stepping down, which really makes it quite slick in here. Levels, it's already got our levels found since we're looking at the target model versus our stock, as well as our iMachining, so we can see that we're having 3 cuts that are very good, and we're going to have 1 cut that is going to be taking a real thin slice cut of what's going on there, as well as we're doing a scallop. No, sorry guys, we're working in metric here. So we're doing a 1.32 millimeter scallop in there, but from right here, like I said before, grab a tool, save and calculate. And like I said before, what it's going to do is it's going to do our scallop that we're looking for in there with that large tool, come back with that smaller tool and get any of the remaining stock there. Plus, I didn't have to figure out a feed and speed, which is really nice.
You know what, Kevin? That it's another really good point. So if I'm a new user and I have to figure out how to use this program, and I'm like, oh yeah, well I have a 1/2 inch end mill and I'm cutting aluminum. Is there a way for me to kind of easily, walk through that and understand, machining parameters and all that sort of stuff? I mean, I know you went through the iMachining wizard. I think that's probably a good place to start. Would you agree with that?
Yeah, absolutely. The hard thing is what we're finding in industry is the machining is almost getting to be almost a dying trade. And what's happening, we're seeing from our technical chairs, Greg and myself, and the rest of the technical staff, is there's a lot of people that are out there machining parts that have never totally understand machining, what's a good chip load, RPM, stuff like that, where now this takes that guesswork out for you guys, and you can just base it off of your technology wizard right here of how aggressive you want to be in that cut. So
sure.
If I'm a brand new machinist, I like to call it the guy in Montana, the surgeon. Never machined a part in his entire life, and he was up and machining within that second day with cutting chips, and a lot of 3D iMachining that was being utilized in there, even though that, you know, the 3D iMachining is designed for 3D complex geometry like this, can be used in that 2D content. So
Sure. That's awesome.
So if we go and simulate this here.
Do these simulation tools come with the system, Kevin?
Absolutely. So what you guys will get, for those that are watching that don't have SolidCAM, you will get all these simulation packages right up here, minus the machine sim. Now the machine sim is an additional add-on there, but what you're viewing right here is our Solid Verify. So you'll have all your crash detection in here, along with your fixtures or your vices that you're using, crash detection against your holder. It will throw an alarm telling us that our holder is hitting, or we're shanking out, or we're machining off our jaw in any scenario. And now you can see we came in there with that 16 millimeter, and it was actually a bullnose end mill. And now we're coming in here with the 8 millimeter bullnose end mill as well. Now, one thing to kind of remember is 3D iMachining is going to be work best with a square end mill or a bullnose end mill. Technically, you can use a ball end mill in there, and you will have to turn that option on. But with the ball nose end mill, since it's based with the ball of the tool that's there, you may get some drag marks every once in a while. And I'll show you where that option is, and they have a little warning telling you that it's not 100% supported by it, but you can, you do have the option there. And that's one thing I really like about the iMachining versus all the other CAM packages that are out there. A lot of other CAM packages do have a high material removal system out there. Nothing that's near what we can do here, but what I've seen from those other CAM softwares is you don't have control of what you can and can't do. Where here with the 3D iMachining or the 2D iMachining, you guys do have full control. So we can control, maybe I want to cut my spindle RPM down, or maybe I want to reduce the amount of horsepower that is being required by the spindle using a different tooling in there. All that, you guys have full access to the control of that.
Well, the other thing too, Kevin, is like, I mean, everything we talked about in terms of tool libraries, bringing all that stuff, that information in, I think the long story is very short here, is that, this is really designed for maximum material removal, and then also tool life. I mean,
yeah,
people don't really think about that a lot of times. And, I know there are some videos, and I'm not sure if you're if you're going to show them tonight, but wow, we have some amazing videos that show just tool life beyond anything you could believe, even in older machines too. This doesn't apply to just the latest technology. We make iMachining successful in machines that are 30 years old. It's really incredible to watch. So
yeah, and that's a great point too, because I just lost it.
Uh-oh.
It was on the tip of my tongue, but
lost your marbles?
Yeah.
Or...
yeah. What was I going to say with that?
Oh no, you were going to talk about the video that Ken did, Ken Merritt, with the.
No, it was. Dang it, I lost it. Maybe I'll get it back here.
Okay. Well, we'll help you get your meds. You'll be fine.
Yeah.
Everything's good.
So now you guys can see that we have this part.
I doubt the 84 thing.
Yeah. So now you guys can see that have this part completely roughed out. And the nice thing like you'll see right here, if I can get a good side view, is no matter where we're at, the scallop is always maintaining a constant height. So if we go from right here on a more vertical wall versus over here, you'll see that the step overs, you know, right here, or the step downs are much closer versus over here, they're much farther apart. And what we're doing is, like I said, we're maintaining that constant scallop height. So when we come back to do a finish pass on here, we have that real nice even load on that tool the entire cut for you guys. So, boy, it's bugging me what I was going to say now. But okay, I just can't think of. It's bugging me real bad now.
Yeah, we're gonna have a special supplement KevCAM night class at 3 o'clock in the morning when you remember it.
Yeah, exactly.
I was just going to say, Kevin, the key to that is try to think about something else, and then it will automatically come back to you. That's what happens with me.
For those in the audience, don't confuse it with KevCAM After Dark.
Yeah. So one thing I did want to show you guys too is with the control that you guys would like in there. So you guys can come over to the modify cutting conditions, and like I said before, you can come in here and tell it, well, you know, instead of a 0.07 millimeter chip thickness, I want to go something smaller, or, you know, maybe I'm worried about the horsepower that it's going to be requiring at the machine. And that's where I just remembered it now. So getting back to the horsepower, I know Brendan was talking about, you know, how, you know, iMachining is going to increase your tool life, decrease your cycle time. But one thing to remember, when we're using iMachining, we are utilizing high feed movements. So what I mean by that is when that tool goes to reposition into another area, it is using a G01 with a high feed move. So for those of you guys that switch back and forth between a G00 and a G01, you always have that moment of time where the machine has that quick little stutter, and then it keeps going, where with 2D iMachining or 3D iMachining, it's going to stay in that constant G01 move, keeping the machine from jerking. As well as, you know, if we get into a corner here, it's getting a little hard to see, but getting into these tight corners right here, you know, where normally you would get a chatter, you won't get that anymore just because we're not over engaging the end mill. But back to, you know, Brendan's point with the get faster cycle times, you will also see a longevity of your machine just because we're not ramming that tool into the corners anymore. So it's going to be much easier on your ball screws of your machine. So, you know, in my eyes, it's a win-win all the way around because we're going to save your machine life. It's easy to program, as well as get better tool life and decrease the cycle time. So quite a few different wins there.
Oh yeah, you know, definitely, Kevin. And, you know, and that's the whole thing, like that acceleration, deceleration time that has to happen between, like you said, you know, a G0 move or a G1 move. You know, why keep flip-flopping back and forth and causing undue stress on the machine? So, you know, keep it in that G1 move and then just, you know, accelerate and decelerate the feed rate. Makes perfect sense.
Yep. And when you guys are looking at the path right here, I mean, if we take a corner right here, you won't see any 90-degree corners in here. They're all nice radius corners, so we're not getting that machine jerk going from Y positive to X positive. It's all nice.
Yeah, exactly. Like no sudden stops and starts. You know, it's perfect.
So now, with that being said, that is about all that at least I can think of. I know Greg's got something that I'm really afraid to even ask him what he's gonna ask, but let's go for it, Greg.
The only thing I was going to say is that everything that we've seen so far is iMachining applied to milling centers. And just letting everybody know that these same toolpaths that you see can also be applied to mill turn machines as well. Any mill turn or Swiss, if you do have the 2D iMachining or 3D iMachining, you can still take advantage of these toolpaths. Obviously, you're not going to be doing a ton of huge material removals, but where it really comes in handy is protecting those smaller diameter tools. So if you are using some small end mills to do some face milling on a mill turn center, because we are monitoring that angle engagement, you can really protect those tools and get some very high efficiency removal rates using iMachining on mill turn center. And that's using the XY axis, and you can also do it in an XC with iMachining, where you're using the spindle to rotate as the X is modulating. So very powerful stuff.
Yeah, great point, because in a Swiss machine, we're not going to see a 1/2-inch end mill hogging away. We're going to see, much smaller end mills, just because for those guys that have never worked on a Swiss, it is extremely tight in there, and what we can and can't do. So a lot of times, Greg's point here, that you'll see much smaller tools, and that's, when iMachining first came out, and this was back when I was on the shop floor, I called in and they came out with iMachining back in 2000, I think it was 6, and told me to try it, but try it with a smaller end mill. And that's right when the big recession hit, where, any dime that we could save, we need to save money here. So instead of paying for, let's say, $100 1/2-inch end mill, we were able to utilize a $25 1/4-inch end mill and still get the same performance as if we were running a 1/2-inch end mill with traditional machining. So great point, Greg, because when we're getting into those Swiss or the mill turn machines, size is always, there's just not enough room in there, because we're trying to compact so many tools and tool holders and collets and all that stuff into a small space. So now you guys can utilize those smaller tools in there, but still get much better results, as well as with our live tooling.
And even on the milling side.
Mm-hmm.
Like, I've been in shops where guys are cutting electrodes for EDM machines, and they need a very fine resolution. So these guys are using 20 thousandths diameter end mills, and you do not want to put any kind of stress on that diameter of an end mill. Like, just looking at it, you're afraid you're going to break it. And with iMachining, we're able to make those cuts and have the tool last. So yeah, it's applicable across all applications. So.
And one thing I highly suggest doing, if you guys are a little bit newer getting into this 3D iMachining, have questions on tool or tool holding, and this definitely goes for people that aren't even our customers, utilize our tech support line, because as I kind of said before with Brendan in the 1984, I'm the youngest. Well, no, yeah, Greg, you're a year older than I am. Greg and I are the youngest ones here, and SolidCAM would not hire anybody with a 10 years or less shop experience. So both Greg and I and all the tech team have been in the trenches. We definitely don't know it all, but we can definitely get you great recommendations of, what to use in a specific application. So definitely give us a call. That's what we're here for, is to help you guys out. So.
Yeah, and that is not an average either. I mean, don't think that we're using Brendan to sandbag that experience requirement.
No, it's and Greg, it's a really good point. We do have some younger guys on the team, but we have very seasoned professionals on this team who have been in this industry. I mean, programming, machining, fixturing, tooling, you name it, and they have 40 plus years of experience. So I'm proud to be a part of this team, and that's really, I think, we're getting close to the end of this here, but I really can't explain the importance of support any more than I can here. All of our guys are, again, like I explained, just super intelligent guys, no machines. They're based in the United States. That might offend somebody if I say that, but I certainly don't mean it to. people in every time zone. So, you know, the support is there pretty much anytime you need it. So, yeah. Anything else, Kevin, or did I miss something?
I think that about wraps up. Do we have, for the people that are watching live right now, any questions that come up along the way? It's, you know, and if you guys do run across questions, for those of you that are watching this on YouTube at a later date, my email is down in the description below. Definitely feel free to reach out to me, shoot me an email, let me know how we can help you out. If you guys are looking into, for those of you guys that are here in the United States, and you don't have 3D iMachining, let me know, and I will get you hooked up with your account manager to get that squared away. Or if you know who your account manager is, definitely give them a call. I know for the SolidCAM USA, they're running some pretty sweet deals going on right now. So now's the time to do it if you guys are kind of on the fence about it. But, all right. Well, with that being said,
Kevin.
Yeah.
Well, real quick, just for anybody that's catching this on YouTube, do you have any teasers on what the next class is, or where they can find the sign up for the next class?
Absolutely. So if you guys come over to our website, and come to subscription, or I'm sorry, webinars, and go down to KevCAM webinars, you'll see here's where you guys can get signed up for the live class, as well as, you know, if you missed the class, we can definitely watch it on, or you guys can watch it on YouTube later. But so next week we will be covering HSS constant Z, and we're actually going to be diving deep into the HSS, which is high speed surfacing. And there is a lot of options in there to really get the most optimal surface finish that you guys are trying to achieve. So we went through this HSS, had have been like 4 years ago now. Was it, Greg? 3 or 4 years ago that we covered HSS? Well, so long ago that we can't remember.
I know it's been, yeah, 3 years for me, but probably much longer for you.
Yeah. So what I did
there's
is,
you know, there's actually a lot of stuff in HSS too, Ken. I mean, it's
absolutely
great product.
Yeah. So what I've done is I'm breaking the HS up into what each one does. So we're going to cover some constant Z next week. The week after, we're going to go into linear, and the week after that, we'll get into hatching, parallel cuts, parallel perpendicular to curve, morph between boundary curves. There's a whole lot in there that a lot of people don't know about. So I really want to cover that in depth as much as possible. Now, the one thing to remember is it does show 8 p.m. Eastern. This is actually 9 p.m. Eastern. So we'll get our website fixed here for you guys. So, but with that being said, and if you guys that are watching it live, you guys can always come over to the SolidCAM University channel, and there is a video on how to do everything inside our software in here. And if not, let me know, and either myself or Mark will come in here and make one for you guys. And there's a lot of great content in here. Definitely, if you guys are looking just for a specific area, come to the playlist. Here's Greg's expertise area in the Swiss area. But if you're looking for some, what does the tool axis direction do in my 5-axis or simulation, both Mark has done a fantastic job of going through and creating a bunch of short videos for you guys in here as well. So definitely come check it out, as well as we have our machining, or how do you say it? Really cool machining videos right here for the live cuts. I was going to say something else, but better not. Okay, I'll stop rambling here, and we will see everyone next week for the HSS Constant Z. All right, thanks everyone.
Awesome. Thanks, guys.
Have a good
Take care.